Hi, welcome to my video on the combinations of transformations on ordered pairs. The order of transformation is RST. R stands for reflect, S for stretch, T for translations. So any ordered pair, the translation is reflected first, then stretched, and then translated. So RST. The mapping rule is x comma y, and the negative on the x is reflected in the y-axis. The A is the stretch value on the x, and the plus minus h is moving it left or right. The negative on the y means it's going to be reflected in the x-axis, and B is the stretch on the y that's multiplied or half or whatever it may be, and plus minus k means that plus is up and minus is down. Note A and B are positives. It's only if it's negative that'll be a reflection. And again, this notation here for the mapping rule, the negative with the x is reflected in the y-axis. The A is the horizontal stretch because it's with the x. The plus or minus h is the horizontal translation. Plus is to the right, minus is to the left. And the negative with the y is reflected in the x, and the B times the y value is the vertical stretch, and the plus or minus k is the vertical translation. Plus is up, minus is down. And note, when you're reflected in the y, it's the x that's changing. When you're reflected in the x, it's the y that's changing to the opposite sign. So, for each mapping rule, state. So I have the mapping rules here, and let's fill in these. Mapping rule x, y, map to negative x plus 2, 3y minus 1. And notice the negative with the x, that's a yes, it's reflected. The horizontal stretch is neither, it's a 1, so it's not stretched, 1. And the horizontal translation is 2, so it's 2 right. And the, notice, reflected in the x-axis is a no because it's a plus. The vertical stretch is a 3 times y, so the vertical stretch is 3. And the vertical translation is negative 1, so it's 1 down. And the second one, x comma y mapped to x minus 4 negative y. And because the x is not negative, the reflection in the y-axis is a no because it's a positive. And there's a 1 in front of the x, so there's no horizontal stretch. The negative 4 means it's gone 4 left. And the negative with the y means it's reflected in the x-axis, yes, because it's a negative. And there's a 1, so the vertical stretch is 1, and there's no 0. There's no plus or minus there. It's not moved left or right. So x comma y, 2x, and y plus 6, there's no negative. And the horizontal stretch is 2, because it's 2 times x. And there's 0, it's not moved left or right because there's no plus or minus on the end. And y plus 6 is a no, because it's positive. And the vertical stretch is a 1 because there's a 1y. And the vertical translation is a plus 6, so it's up 6, up 6. D, we have 3x plus 4 as a transformation, so it's positive, so there's no reflection. The horizontal stretch is 3. The horizontal translation is a plus 4, so it's 4 right. It's a negative with the y, so it's reflected, yes, because it's negative. And the vertical stretch is 1. Or you can just say there's no vertical stretch because it's not changed. And minus 2 means it's down 2 or 2 down. Okay, e, x to x plus 3, there's not reflected, no, because there's no negative. The stretch, the horizontal stretch is 1, and it's plus 3, so it's 3 right, or right 3. And in terms of the y, we got a negative, so it's a yes, because it's a negative. The vertical stretch is 2, because it's 2 times y. And plus 1 means it's 1 up. And the last one here on this set, x comma y negative x, is a yes, because it's reflected in the y-axis because it's a negative. The stretch is 1 horizontal, and there's 0 horizontal translation because there's no plus or minus. And the y, there's no negative, so it's not reflected in the x-axis. The horizontal stretch is a 1 with a 1y. Negative 3 means it's 3 down. Hopefully you're making some sense into the combinations. And again, just to remind you, the reflections it's R, S, T. For the, when I say reflection, just then I meant for translations. It's reflect, stretch, and translate. That's the order that you always work out the mapping rule. State the mapping rule for each. So the mapping rule, it's reflected in the y, yes, so that means the x is going to be negative. The horizontal stretch is 1, so we just put 1, there's a 1x. And the horizontal translation is 7, so there's a plus 7. And there's no, reflected in the x is none, so there's no negative. The vertical stretch is 4, so it's a 4y. And that's a 3, so that's a plus 3. B, we have the ordered pair. We have no, so it's not reflected in the y-axis, so there's no negative. The horizontal stretch is 2, so it's a 2x, and the horizontal translation is a minus 1. Reflected in the x-axis, so it's a negative with the y. 1 is the vertical stretch, so it's just a 1y, and 4 plus 4. C, yes, reflected in the y-axis makes the x negative. The horizontal stretch is 5, so it's a 5 times x. And there's no here, it's not moved left or right, so it's a 0. And it's not reflected in the x-axis, so there's y is not negative. The vertical stretch is 9, so it's a 9y. And the vertical translation is a minus 2, 2 down, so it's a minus 2. D, no reflection in the y-axis, so the x is not negative. Horizontal stretch is 1, so it's a 1x. And 6 plus 6. It's kind of 6 right. Yes means it's a negative with the y. The stretch is a half. The vertical stretch is a half, so it's a half y. And plus 10. And we have the last one here in this set. We have a yes, so it's a negative with the x. In other words, reflected in the y-axis makes the x negative. Stretch, horizontal stretch is 3, so it's a 3x minus 4. Yes, reflected in the x-axis means the y is negative. The vertical stretch is 4, so it's a 4 times y. And the vertical translation is 7, so it's a plus 7. So just writing it different ways, variations, switching them, how you write the mapping rule. Number 3, describe the transformation of each mapping rule. Okay, let's look at the x's first. X to x plus 1. So it's the only change is a plus 1. So it's gone 1 right. Now we look at the y. There's only change is a minus 4. So that's minus 4 is down 4 or sorry, down 1. Sorry, down 4 or 4 down. B, we have no negative, so it's not reflected in the y. We have a horizontal stretch. That's the x I'm dealing with. The horizontal stretch is 3, if you're dealing with the x. And in dealing with the y, it's a negative, so it's reflected in the x-axis, because the y is negative. There's the vertical stretch is 1, but we don't say it. And it's plus 6, so it's 6 up or up 6. C, the x is changed to a negative, so it's reflected in the y-axis. So when you change the x to a negative, you reflect it in the y. When you change the y to a negative, you reflect in the x, just the opposite. Negative x reflected in the y-axis. And the vertical stretch is 2. No plus or minuses on the end, no negative in the front. So there's no negative, so it's not reflected in the x. No plus or minus on the end, no translations. D, x minus 2 is gone 2 left. And it's negative on the y, so it's reflected in the x-axis. 5 times y, got a vertical stretch of 5. And a minus 3 means it's gone down 3. Because it's on the y, a negative on the y makes it go down. A positive on the y makes it go up. And on the x, on the end, plus minus 2 makes it go left and right. In this case, the minus 2 makes it go left. E, we have an x plus 8, so it's gone 8 right. And on the y, we have a vertical stretch of 3, and it's gone plus 1, so it's 1 up. Okay, let's continue. More to do. The more you do, the more you practice. And again, pause the video and work them out yourself. And press play again to see if you're right. That's one good way to see if you know what you're doing. Write the mapping rule for each. You notice I'm always switching back and forth. So it's reflected in the x. Let's deal with the x first. So we got an x comma y. Oh, the pen is used out or not working. Okay, here we go. So there's the mapping rule coming. So let's see. Reflected in the x. So that's, if it's reflected in the x, it's changing to y. So that's the negative on the y. Got a vertical stretch of 2, that's the y, so it's a 2y. 2 times y. It's right 4, so that's a right is a plus, so it's a plus on the x. And it's up 3, so it's a plus on the y. So reflected in the x means the y is negative. When you reflect in the x-axis, you make the y negative. And vertical stretch is on the y 2 times. To the right, it's dealing with the x. Up, dealing with the y. B, reflected in the y-axis. Again, we got the order pure x comma y. Here we go. Reflected in the y, you make the x negative. The horizontal stretch is 3, so that's 3 times the x. And it's gone down 7. So down is in terms of the y. So it's a y minus 7. Down is a minus. And C, x comma y going to, let's see what we have here. We have a vertical stretch of 3. The vertical stretch is in terms of the y's, vertical stretch of 1/3, so it's 1/3 times y. Left 6, that means it's a minus on the x, a minus 6. Up 1 is a plus 1 with the y. And so there's no reflection in the y-axis. There's no horizontal stretch, so it's only x plus 6 because of moving left. The vertical stretch is with the y. And again, reflected in the y-axis. Reflected in the y-axis is affecting the x, so it's the negative on the x. And there's no horizontal stretch, so it's just a 1 understood. And the vertical stretch is 5, so it's a 5 times the y. It's gone right 2, so that's with the x, so it's a plus 2. And it's gone down 4, it's a minus 4 with the y. So again, if you do your reflections first, the negative on the x's and the y's, you do your stretches next, horizontal and vertical, which is the number in front of the x and the y, and then you do your translations. So you can work with all the x's first in relation to horizontals, or you can work with the y's. So it's your choice. Here we go again, an ordered pair x, y. So let's do it this way. Let's do the reflections first. Because remember, it should be what? An R, S, T. Reflect is reflected in the x-axis and the y-axis, or both. So there's a negative with the x and a negative with the y. Horizontal stretch of 3/4, so that's 3/4 times the x. And there's no vertical stretch, so the 1 with the y. It's gone 1 left, so there's a minus 1 on the x. And 6 up is a plus 6 with the y. So if you do your reflections, then your stretches, and then your translations, that's the way I do it. State the coordinates of the image of 3, 2, if. Let me do this 2 ways. Here we go. Let's take the point. Let me do this now. Let's take the point 3, 2. X is 3, y is 2, right here. There's the point 3, 2. So now, let's reflect it first. Reflect in the x-axis. Reflect in the x-axis makes it come down to right here. So that's 3, negative 2. Now, translate it 4 left. So if we go 4 left, we go 1, 2, 3, 4 right to here. So that point becomes negative 1, negative 2. And then you have to move it up 2. So move it up 2, 1, 2. So there's the new point at the end. So that's negative 1, 0. So the final result is a negative 1, 0. So if you reflect it, and there's no stretching, and then you translate, so it moves, reflect here, left 4, up 2, and you get this point. Now, if you do that with the mapping rule, watch what happens. If you not plot it at all, watch what I'm going to do now. If you reflect in the x, then that makes that a negative 3, 2. Then if you translated 4, you add on 4, or from 4 left, you take away 4. So negative 3 minus 4, 2. That makes it, that's 3. You better be careful. 3, 2 makes it, when you reflect it, in the x, you change the y, so it makes it 3, negative 2. So this is 4 left is negative 1, negative 2. Again, When I reflect, I change, reflecting the x, I change the y to a negative. When I move it 4 left, I take 4 off the x value to make it -1. And then when I move it 2 up, I go -1. So that's -2 plus 2 is 0. So I get this point. Or you can do the mapping rule. You can do x comma y like that. Reflected in the x changes the y to a negative. Translated 4 left, there was x minus 4. 2 up is a plus 2. Now, take the ordered pair and put 3 in. And put 2 in. And that gives you -1, 0. So you can map it. You can do one at a time like I'm doing here, or you can do the mapping rule. Many ways to do it. And the vertical stretch of 2 is 2 on the y, so that gives me 2 times 2 is 4. And now we're going to take this point and move it 1 right, and 1 right is 3 plus 1, comma 4, so that's 4, 4. Or you can plot the point, 3, 2, which is right here. And you've got a vertical stretch of 2, so you're doubling the y value. So 2 becomes a 4, so 2 is 4 high. So that's 3 comma 4. And you're moving it 1 right, so it's moving it to right there. So that's 4 comma 4. Or, again, the mapping rule. Vertical stretch of 2 is 2 times the y, and right 1 is x plus 1, and you put the ordered pair in, 3 for x, 2 for y, it gives you 4 comma 4. Whatever way you want to do it, as long as you know what you're doing. And try not to make a mistake like I do sometimes. Number 6. State the coordinates of the image of -2, 1 if. So, we can graph it, or we can do the mapping rule. Let's try the mapping rule first. X comma y. What is the mapping rule? So, the mapping rule is reflected in the y. Reflected in the y changes the x. Reflected in the x changes the y to negative. And it's down 2. So, there's nothing else with the x. The y is negative. Down 2 is a -2. So there's the mapping rule. So if you take the point -2, 1, and you sub it in, it's a negative of a -2, comma, a negative of -1 minus 2. So that gives you 2, and 1 minus 2 is -1. And so it's reflected and moved down. So let's do it another way. Let's take the point x is -2, y is 1, which is right here. Now, reflected in the y. Reflected in the y moves it. That's 2 to the left, so we move it 2 to the right there. And then we reflect it in the x. So it's reflected this way, moves to there, and we move it down 2. Down 2. See, I should be down here. How come I have a mistake? Now, what did I do? Reflect in the x, reflect in the y, and down 2. Ah, there it is. This is a 1. I put in the point, I put a negative right here. This should be a 1. My mistake. That's a 1, so I put a 1 in, so that gives me -3. I always make those little errors. That's a 1. I put a -1 here. I don't know why, but I just did. So there's a 1, put a 1 in. The negative of 1 is negative 1 minus 2 is negative 3. Now we're right. Again, I check myself. Again, just one of those little errors that I make. Gotta be careful. And B, a horizontal stretch of 2, a vertical stretch of 3, and 4 right and 3 down. Again, let's do the ordered pair, as in the mapping rule. Horizontal stretch of 2, so it's 2 on the X. Vertical stretch of 3, so it's a 3 on the Y, 3 times. Right 4 is a plus 4. Down 3 is a minus 3. So we take the point, negative 2, 1. Plug that in, or sub it in, I should say. Same. So I'm subbing in. Negative 2 in place of X, 1 in place of Y. That gives me negative 4 plus 4 is 0. And 3 minus 3, that's a 3. Subtract 3 is 0. So the point is 0, 0. And if you want to take the point is negative 2, 1 right there. So the horizontal stretch is 2. So that makes it a minus 4 right here. And the vertical stretch of 3 is 3 on the 3 times 1 is 3 right here. And it's gone 4 right to here. 1, 2, 3, 4. And down 3, 1, 2, 3. Perfect. Perfect. Sometimes it can be awkward. You just got to be very careful in what you're doing. And that's a review of the transformations combinations. It takes a while to get used to working with the transformation non-ordered pairs or the transformations on any of the graphs you're going to do. If you like my video, click the like button, click the subscribe button, click the notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.